G'day YouTube, Warbles on a lot here, with an article read from New Scientist magazine, dateline 30th of May 2015. Article titled Invasion of the Mind Snatchers by Colin Barras, a science writer who lives near Ann Arbor in Michigan. The idea that a feline parasite might hijack our brains sounds like a B-list horror movie. It isn't, says Colin Barras. Imagine there were a parasite living inside your brain, an alien interloper with the power to alter your neurochemistry, manipulate your behaviour, and change the way others see you. It might even rob you of your sanity. You are not the only person affected. The creature has taken up residence in the brains of billions of people, and many more are at risk. This is not fiction. This mind snatcher actually exists. We already know that some parasites mess with their host's mind. The lancet liver fluke, for example, induces suicidal behaviour in any ant it infects, making it climb to the top of a blade of grass and hold on tightly with its jaws until it is eaten by a passing cow. Thus, the fluke gets back inside an animal in which it can reproduce, completing its life cycle. It is not the only parasite capable of such mind control, but generally their targets are insects and other small-brained invertebrates. Influence over a mammal with the brain size of a human was beyond their capabilities, or so we thought. That assumption is being challenged, at least for one parasite. You may have heard of it. The microbe in question is Toxoplasma gondii, a single-celled protozoan that infects many birds and mammals but reproduces sexually in just one group, cats. Humans generally acquire it by eating undercooked meat and unwashed fruit and vegetables, or from cleaning litter trays of cats that have been recently infected. Pregnant women and people with immune disorders such as HIV are advised to avoid these risks because toxoplasma can occasionally be fatal to a fetus or to someone with a compromised immune system. But for most of us, a mild flu-like illness is the worst we might expect. The symptoms of toxoplasmosis can be so innocuous, in fact, that most people don't even seek treatment. Soon, usually without us knowing we even have the parasite, it enters a latent phase. It forms cysts, mostly in the brain, and it hunkers down inside them, sitting dormant for decades, apparently doing nothing. Suicidal combination. Worldwide, at least 2 billion of us carry the parasite. Some estimates put it at twice that. The only hint of its presence comes in the form of toxoplasma antibodies in the blood, or so we thought. But toxoplasma does have form as a mind snatcher in other animals. We know that it boosts its chances of ending up inside a feline gut by messing with the minds of mice and rats. In the mid-1990s, for instance, researchers including Joanne Webster, now at Imperial College London, UK, discovered that toxoplasmosis makes rodents more active and less fearful, a suicidal combination that increases their likelihood of being caught by cats. The consensus was that the parasite could not pull off a similar trick in humans, but one man suspected otherwise. Evolutionary biologist Jaroslav Fleger at the Charles University in Prague, Czech Republic, decided to investigate its effect on human behaviour. His findings surprised many people. In 1994, Fleger and colleagues reported that men infected with the protozoan were more likely than uninfected men to disregard rules or to be excessively suspicious or jealous. A few years later, he used a computer-based test to show that infected men and women have significantly delayed reactions compared with uninfected individuals. The work attracted little attention at the time. Then, in 2002, Fleger tested people responsible for traffic accidents in Prague for infection. The results confirmed his hunch. Car drivers and pedestrians injured on the city's roads were more than twice as likely to be infected as a comparable group of people living in the same area. As in rats, the parasite appeared to be linked with reckless behaviour. The finding, which has since been replicated by other groups, has encouraged others to question whether toxoplasma is more harmful to humans than we imagined. Another factor contributing to the shift in attitudes is Webster's discovery of the way in which the parasite exerts its mind control over rats. In 2000, she reported that toxoplasmosis doesn't simply make rats less fearful, it actually alters their sense of attraction, so that they find the smell of cat's urine alluring. Infected rats retain their aversion to the urine of other animals, leading Webster and her colleagues to dub the effect, quote, fatal feline attraction. It no longer seemed likely that the personality changes seen in rodents and people with toxoplasmosis were merely a standard sickness response. Mammals have a naturally evolved suite of sickness behaviours, such as withdrawal and fatigue, but Webster's discovery of the powerful and precise way in which the parasite controls the mammalian brain suggested something else was going on. What might that something be? A study in 2009 provides one possible answer. Glenn McConkey at the University of Leeds, UK, and his colleagues were analysing the toxoplasma genome when they found something unexpected. The parasite carries two genes for trizone hydroxylase, an enzyme that helps produce a precursor of dopamine. There is no obvious reason why the parasite itself would need lots of dopamine, but in the mammalian brain, dopamine acts as a neurotransmitter, playing a role in motivation, cognition, pleasure, and fear. Could toxoplasma be meddling with the brain chemistry of its hosts to change their behaviour? It certainly might be. As early as the mid-1980s, researchers were reporting elevated dopamine levels in rodents with toxoplasmosis. And a few years before McConkey's discovery, Webster and her colleagues found that haloperidol, a drug that inhibits dopamine production, prevents infected rats from displaying fatal feline attraction. But what about humans? Psychotic connection. It's not really known whether people infected with the parasite have elevated dopamine levels. Intriguingly, though, haloperidol is prescribed to treat schizophrenia, a mental condition thought to be caused in part by overactive dopamine systems. We already know of a correlation between toxoplasmosis and schizophrenia, and in 2008, researchers reported that people with toxoplasma antibodies had an increased likelihood of developing schizophrenia, adding weight to the idea that the parasite might actually trigger the psychotic condition. Other teams have not yet managed to replicate the finding, but evolutionary biologist Paul Ewald at the University of Louisville, Kentucky, believes it is only a matter of time before the link is accepted. A strict genetic argument for schizophrenia just can't explain all of the evidence, he says. In other words, it can't just be down to our genes. He believes that about a third of all schizophrenia is triggered by toxoplasmosis. For now, McConkey admits that we still need more evidence to show that toxoplasmosis exerts its control over the minds of mammals using dopamine. To be sure, we would need to block the activity of the two genes involved in dopamine production and see whether this affects its ability to manipulate behaviour. The first steps towards doing that have now been taken with disappointing results. Researchers found that knocking out one of the protozoan's dopamine genes made no difference to the levels associated with toxoplasmosis in rodents. Quote, I have some reservations about that study and the methods they used, says McConkey. However, he adds, it reminds us that we should be careful about jumping to conclusions before we have all the evidence. There may be another explanation for toxoplasma-induced mind control, though. Over the past 5 years, Ajay Vyagas at Nanyang Technological University in Singapore has amassed evidence that toxoplasma doesn't just go to a rat's brain. It also clusters in the testes, from where it can pass to females during copulation, ending up in around 60% of their offspring. In other words, toxoplasmosis is a sexually transmitted disease. Vyas's findings suggest that we have missed something important. Toxoplasma has two goals, he says. It is keen to get back into a cat, but more importantly, it's driven to spread to as many rodents as possible so it can ultimately reach as many more cats. The parasite can achieve both goals by manipulating testosterone levels, says Vyas. Then, not only will infected rats devote more of their time and resources to breeding, they will also throw caution to the wind while they do so, boosting their chances of being caught by a cat. His findings support this idea. For instance, male rats with toxoplasmosis are judged by females to be particularly attractive, and the odour of cat urine induces sexual arousal in rats with toxoplasmosis. Agai's work is quite intriguing, said McConkie. It does raise the possibility that there's a lot more going on than we currently understand. Curiously, some parallel effects have now been reported in humans. Flegger has found evidence that men with toxoplasmosis have an unusually high levels of testosterone and tend to be viewed as particularly masculine and dominant by women. So does toxoplasma pull most strongly on human brains or human groins? This is speculation, but I don't think there are multiple controlling strategies, says Voyasas. I think it's the same strategy with multiple nodes. My goal is to find the circuit that connects it all up. It is debatable whether toxoplasma is deliberately manipulating human behaviour, as some other parasites seem to. Unlike rodents, we are not eaten by cats, so any mind-bending effects of the protozoan could be unintended. On the other hand, our distant ancestors certainly were prey to big cats, as are other apes today. What's more, in 2011, Flegger reported that infected people experience, quote, fatal feline attracted too. Cat ladies are attracted by the smell of cat piss. Quote, there is no reason to think that toxoplasma is better adapted to mice than to apes, he says. So how can we stop this mind-controlling parasite? For now, the answer is we can't. The main problem is that the parasite's fatty cysts are almost unimpregnable to drugs. There is one way in, however. It's unclear how, but the cysts will swallow molecules called transductive peptides, and in 2012, researchers led by Rimmer McLeod at the University of Chicago managed to attach an active drug to these molecules and get the killer agent inside toxoplasma cysts. It was an exciting discovery, but funding for such work is hard to come by, says team member Bo-Xian Lai, now at the University of Cambridge. I'm hopeful that our approach might lead to an effective commercial therapy against toxoplasmosis, but this will realistically not happen anytime soon. In the meantime, how worried should we be? Flegger believes the link between toxoplasmosis and traffic accidents, schizophrenia, and possibly other mental illnesses too, means it must have a huge economic impact. Exactly how much of the impact is unclear, but Ewald points out that the total bill for treating schizophrenia in the US is $63 billion with a B dollars per year. If toxoplasmosis really is responsible for 1/3 of all cases of schizophrenia, it could easily cost the US $20 billion a year. Of course, this sort of estimate doesn't take into account the non-economic quality of life costs, which I consider to be even more important, he adds. Toxoplasma also presents us with an opportunity, says Shelley Adamo at Dalhousie University in Halifax, Nova Scotia. Parasites like toxoplasma are evolution's neurobiologists, she says. Careful study of the mechanisms they have evolved to manipulate behaviour might offer neuroscientists some handy tips on how to treat disease and addictions. A parasite that makes its host less fearful could really come in handy. After all, excessive fear is a characteristic of many conditions, from phobias and social anxiety to post-traumatic stress. Perhaps one day we will be able to manipulate the manipulators. So not only does Puffy Cat infect the bag lady or the cat lady with toxoplasma so that any pregnancy the cat lady has is likely to spontaneously terminate, and the cat lady will be attracted to the smell of cat piss, and they'll behave recklessly, spontaneously, energetically, but without thinking, so they're likely to hurt themselves. The whole idea was so that saber-toothed tigers could catch and release humans and let them infect other humans, so they'd be easier for saber-toothed tigers to catch and release. And why has it happened to us? Because 11,000 years ago, at Gobekli Tepe in Turkey, they invented Broadacre harvest everything aggroculture, and to store their grains, they needed cats to keep the rodents down. So it was humanity's invention of Broadacre hybridised agriculture, deforestation, desertification, putting the topsoil at the bottom of the ocean, to grow the grain, to bring in the cats, and ever since then, Egyptian pharaohs were patting cats. The Emperor of China was patting cats. The King of Siam was patting cats. We've had cats introducing toxoplasma so that all our ruling classes who could afford to have a cat are suffering from toxoplasmosis, so that they're all permanently drunk and half crazy, impulsive, impetuous, delinquent, recalcitrant half-wits, all because of the cats and their protozoans. The puffy cats are using biological warfare to neurologically control humans as slaves. And that's the thing that dogs do not do, and neither do horses. Neither do kangaroos or swamp wallabies. Warbles on a lot to YouTube. Beware the puffiest catus. Ciao.